Hello everybody, and welcome to today's presentation, How to Run Databases on Containers, Docker, and MariaDB, brought to you by MariaDB. I'd like to introduce you to our presenter. Thomas Boyd is a Principal Solutions Engineer at MariaDB. Thomas joined MariaDB in 2017 and brings with him 25 years of experience in the IT industry with a focus on databases and data storage technologies. Well, without further ado, I'm going to turn things over to Thomas to begin the presentation. Thomas?
All right. Thank you, everyone, for joining. Good morning, good afternoon, good evening, wherever you are around the world. We're going to spend about the next 45 minutes talking about containers and Kubernetes and databases. So let's jump right in. I'll first say that I do welcome questions throughout. Please use that question functionality inside the presentation software. I'll attempt to pause throughout the presentation and field some of those, and time permitting, we should have a fair amount of time at the end for a Q&A session as well, which always brings more value to these kinds of presentations. So for a high-level agenda, this is what we're going to talk about. And I guess I would like to start by saying this is really kind of a high-level introduction to containers, and then we'll talk about some of the challenges of running stateful applications like databases on containers and what the current state of the world is for MariaDB. So that said, we're going to walk through that high-level promise of containers. We'll talk about what's been happening in the orchestration and management realm with respect to containers. Then we'll get into the meat of the presentation on MariaDB and containers. And then I wanted to give you guys a little bit of the lessons that I learned as I got started with this, particularly in development environments for containers. And again, I'll pause for some questions throughout the presentation. So let's talk about the promise of containers. One of the main things that's really getting solved by this revolution in operations, and part of it is DevOps related, is trying to solve the problem where new bugs and new behaviors would present themselves as you moved your application through different environments. When the studies were done about some of the main reasons why, okay, there's a whole new set of bugs that I hit in my test and staging environments, and a whole new set that I hit when I get to production, is those environments differed, and the deployment mechanisms differed in those environments. So you might have a developer who's working solely on his desktop, or his desktop or his laptop, which is, perhaps a wildly different operating system than where you're going to eventually be deploying the production application. And he may be interacting kind of directly with GitHub and doing builds sort of on the fly. Most mature organizations have some sort of a formalized process for promotions into those test and integration environments that may involve things like Jenkins and scripting with things like Puppet or Chef or Ansible. And so you've got a different set of deployment artifacts that you're using then, and a different environment, right? So again, it might be a different operating system with different package levels installed. And for various reasons, sometimes as you move into production, it's a different set as people have kind of isolated what's allowed to happen in your test and integration environments from production. And so it's really frustrating to have these changes where you have to go back and make fixes. Everybody wants this agile environment where you can quickly roll out changes into your production environment. And this was getting in the way, and it's one of the things that containers solve. The other issue is, we no longer have sort of these single monolithic applications where, there's an application tier that is, talking to your one and only data store behind the scenes. We have these composite applications that consist of, legacy databases, perhaps a separate caching layer, perhaps, some kind of a data lake on the side where, long-term data storage is happening. And then, perhaps even applications that are made up of composite services or a microservices environment where you'd like to be able to scale and manipulate each of those separately. And this is great, and part of this whole complex architecture and part of microservices is to allow you to be able to iterate individual services more quickly and get you some of that agility. Unfortunately, while you're getting this agility kind of a little bit on the development side, you've added all this complexity, and it has all the challenges that you see here on the right-hand side for operations in terms of orchestration, the maintainability of this overall environment. How do you manage durability and consistency between the different data stores you have up and running? How do you quickly scale these various layers of your application stack, not just the application tier, but also your data storage tier? And then also kind of this added complexity of it, how do you deploy this in the cloud, or perhaps across a hybrid cloud where some of it's on-prem and some of it's in public clouds. And containers are introducing some ways to solve, some of these challenges that you see on the right-hand side. So, how does it solve some of those problems? First and foremost, kind of around that breakage issue that you have as you promote into your different environments, from development to test, integration, and staging and production, depending on how many environments you have, could be more. The idea is that you're defining a single encapsulated definition of the image that's going to be running to support at least a portion of your application. And that encapsulated image includes your specific OS version and the packages and patches that have been applied to that OS version. Of course, it includes your application code. It includes, parts of your execution environment. For example, if it's a Python application server that's running, it's pulled in the exact version of Python that you want. So by having all of those packaged and up and running as part of the deployment of the application itself, you don't have sort of this separate system administration step where they're constantly trying to keep their machines, their physical machines or virtual machines, in a state that's ready to receive your application. That's all defined together as one image that's going to be deployed. You also have the ability to guarantee process isolation. And people have been doing this for a while with virtual machines and some other technologies. And in fact, containers are built on top of some long existing pieces of functionality inside the Linux operating system around C groups and different ways to fence off memory and CPU and other resources such that you can host separate processes on the operating system but not have them interfere with each other. And the container purists probably don't like to say this statement, but in some ways you can think of containers as just a faster, lighter weight virtualization technology. And it does give you that isolated virtualization, if you will, that you get from some of the many VM solutions that exist. There are, however, a couple of sort of key advantages with going with containers versus virtual machines. Underneath the covers, virtual machines are having to run a whole separate guest operating system for each virtual machine that's up and running. And that adds a fair amount of resources that are required both to start up and then to continue to run those separate operating systems. So there have been some studies that have been done, and the numbers are anywhere to 5 to 10 times as many containers can be placed on a single physical machine compared to the same functionality running in guest operating systems on virtual machines on that same piece of physical hardware. And I think we always want to take those those claims with a little bit of a grain of salt, and in particular, it stands in stark contrast to the quotes from the virtualization vendors that there's really a very small overhead associated with running an application virtualized versus running it on bare metal. And what I always encourage people to think of is, that's true for the single application running on only one physical machine. It may be a 5% overhead to run it in a virtual machine, and there's a lot of advantages you get from running in a virtual machine, so it's a very small overhead. But the equation changes when you're running in these environments where you have where you're attempting to pack many services on single machines. Again, it's because you're carrying that guest operating system in each one of those virtual machines. And this problem, or this kind of somewhat hidden overhead, has become exacerbated lately because of the move towards microservices and smaller components running, and also because of the move towards ever larger and larger physical machines that are able to host, potentially tens or hundreds of these services. The size of machines in terms of CPU counts and memory that are available has drastically changed over the last 5 and 10 years. So we have people who are very anxious to leverage their investments in their hardware, and this is just a better way to be more aggressive about packing more functionality onto a single frame. So a very nice thing happened kind of early on in the life cycle of containers, and there actually are other container standards besides Docker, but most people these days are treating Docker and containers as synonymous. Docker, the company, donated the definition of what a container is and how it's supposed to behave to the Open Container Initiative in the hopes that we could avoid the kind of fragmentation that we had in the virtualization market. So the nice thing now is the Open Container Initiative is a vendor-neutral governance that's kind of modeled after the Linux Foundation that kind of establishes and maintains these standards for the container format and the runtime and those associated specifications. So the great thing now is we've got a lot of people who've joined that Open Container Initiative, and when you define your image, your MariaDB image that you want to execute in a container environment, that's going to work in many, many different container environments from different vendors because they've agreed upon this standard. So a little bit different than the fragmentation we had with virtualization. So that's kind of the first section, just kind of the general introduction to containers and some of the problems they're trying to solve. I would pause right here for a moment and see if we have any questions on that. I'm guessing some of you are old hat with containers and are anxious to move on to the next section. And again, if you want to ask a question, please use the question functionality in the webinar controls. We're not turning on the phone lines at this point. So far, no questions. So I'm going to move on, and we're going to talk a little bit about orchestration and management of containers. And I find the easy way to think about this is to kind of look at some of the original functionality that was added again by kind of this first mover in the container space, the company Docker. What this is showing is that the parts in green, the definition of a container image, and then the Docker engine, which defines how that container is supposed to be run and handled. Those are part of that Open Container Initiative. But you pretty quickly run into this issue of, well, there's more that I want to do. For example, what I really want to have is I want to have my grid of, hardware, my grid of physical machines that are out there all stitched together, ready to receive images and get those images scheduled on these, 10 or 100 machines that I have out there running. How do I do that? Well, Docker, the company, had does have a tool called Docker Machine, which helps you stitch together all of those various physical machines as one grid that you're then going to deploy into. How about those composite applications that I talked about, right? Right now I've been talking about kind of that single image that's up and running. In our case for MariaDB, it's the MySQL D daemon that's up and running. But what about when I want to do master slave? Or what about when I want to stitch together everything from my application stack down to my database and deploy that in one go? Well, that's where some of these higher level definitions are available in Docker Compose and Docker Swarm come into play. So you get these higher level abstractions that help you manage those containers that you're creating and running on in your runtime environment. What's happened over time is originally there were several different thrusts for what that orchestration layer would look like. Docker had their play with what I just showed you. Mesosphere had their own, separate play for how they were going to manage those higher level elements. Again, a lot of the platform as a service players had kind of natural, I would say their own vendor specific ways they were going to do this. There was also a project born from Google called Kubernetes, which was really a container orchestration layer. And what we've seen in the last year is that core Kubernetes definition, which is open source, has itself been adopted by these other platform as a service vendors. So you'll now see OpenShift supporting, core Kubernetes functionality. Likewise with Mesosphere and some of the others. We're also in a really great situation where the public cloud vendors are also supporting this, not just containers now, but this Kubernetes management environment. So obviously Google from the very beginning had supported it. There are various flavors of container services that are available from Azure, Amazon, and the other cloud vendors. So it might be a little bit early to declare Kubernetes as the winner in this space, but it's looking like it's moving that direction, which is exciting for vendors like MariaDB. So now we can consider not just whether we're going to standardize and deliver Docker containers to the market. Perhaps we should be delivering full-blown Kubernetes definitions as well. So that's where that stands right now. I wanted to give kind of a high-level look at some of the Kubernetes components, and I'm going to start by saying, you know, the open source project, which is more or less documented at a website called Kubernetes.io. Again, this was born out of Google, is excellent and has really great tutorials. And for the folks who want to get started on just the vanilla container and Kubernetes experience, I think that's a great place to start. My one critique is sometimes their diagrams are not that great. So I threw this together to maybe give you a visual representation of what's happening behind the scenes. So if you start on the right-hand side of this picture, what you're looking at are 3 physical machines that are up and running. Those are those nodes. But on each one of those nodes, the Kubernetes environment, which for the nodes is expressed as a kubelet service, is up and running. And the kubelet service also includes that core Docker runtime, like the definition of how I'm going to manage containers as they're deployed into my environment. And then those nodes themselves will spin up those individual images, those running processes that are going to support your application or your database. They may also be responsible for coordinating volumes. In theory, those volumes, the storage or the persistent storage that you may want for your containers could live locally on those nodes, or they could be enterprise class SANs or basically network attached storage that's somewhere out there, more or less external to the Kubernetes cluster, but with the ability to connect to them and store data in them. So great, you have all of these nodes that exist where you can send commands to through the kubelet service to create containers and get that functionality, but you need all of those control pieces. How are you going to send your commands in? And that's where the Kubernetes masters come into play. And there's a number of services that run on these Kubernetes masters. You can have multiples running for redundancy purposes, so that if the node that's supporting your Kubernetes master services goes down, another one can step up and take over. Those include things like you know, the endpoint for the REST APIs. It includes networking services so that all of those containers can talk to each other in a meaningful way. It also includes the application server and the web server that's supporting an interface, so you can log on and see your pods that are up and running and perhaps make changes, add more containers. And then, you know, your user interfaces are going to be over there on the far left-hand side. And those include that UI that I just mentioned, a REST API, which is quite useful if you want to do some coding about the way you want to interact with your Kubernetes environment, and then a command line interface called kubectl. So if you're new to containers, this is probably a lot to absorb really quickly, but I wanted to give you guys kind of a layout of what a Kubernetes cluster can look like, at least a high level. So separate from kind of that representation is the representation of the kind of artifacts of the way you declare objects. And we've already sort of at a high level talked about containers and volumes, which are represented here by the little red cube as a container and the blue database symbol or dis symbol as a volume. For a couple of reasons, the management of those are largely encapsulated, or at least the management of the container portion of it is always encapsulated inside what's called a Kubernetes pod. And a pod technically can support having multiple containers run inside it, but for stateful applications like a database, for all practical purposes, a pod maps one-to-one with a container. So that's what you're seeing on the far right-hand side there. In order to have access to a pod from outside and access to a container from outside your grid environment, you need to declare a service that will map the port that the pod is exposing to a service name that people can use to address that. So for example, when you have that single MariaDB up and running, you'll be declaring a MariaDB service in front of it that matches to the port, often 3306, that's open. It gets a little more interesting with the next component above pods, which as a class are called controllers. So for those of you who are familiar with Kubernetes, these are things like replica sets, daemons. There's a special one called jobs. For databases, StatefulSets are getting quite popular for the way to manage pods that are running databases. And this is where you can define things like, hey, I want 3 members of this or 3 versions of this pod up and running. And here are the rules about how they start up. And so what you can think of is as the controller more or less sitting as a watcher over the pods that are running in your Kubernetes environment. And if for some reason one of the pods that the controller thought was supposed to be up and running goes down, it's the one who's responsible for instantiating a new version of that pod and getting it up and running, joining it into the network and making it available for processing. Generally speaking, those controllers would be kind of at a component level. Again, it might be the database, which is only one part of your application stack. Sometimes the database itself might have several controllers, maybe one to control, well, if you're running a complex database, one to control your storage tiers and one to control your parsing tiers. Here I'm talking about MariaDB AX, where even the database itself is kind of broken up into multiple components. So you might have multiple controllers to support that. Certainly, your web tier and your application tier, if you were trying to install that all as one element, you would be stitching that together in what's called a deployment. So again, without spending too much time here, these are the components that you're going to use to declare your functioning Kubernetes application. So containers were really born first to service stateless components or stateless applications. So, you'll find a couple things. In particular, when a container starts, it has some local storage that it can write to, but when that container stops, all of that local storage is thrown away. Additionally, sort of the very early versions of containers in Kubernetes didn't really expect that those pods, would have to communicate with each other and stitch together, for example, as a master-slave-slave setup in MariaDB. So for something like a web server like Nginx, it was really brilliant, right? And there's lots of great examples in Kubernetes.io on spinning up application servers and web servers. What we're looking at here is really a deployment definition. Remember on that last page we talked about deployments. And you can see inside there that it's declaring the specification of that deployment, which is that we want 3 replicas up and running of the Nginx container. And that's where you're looking down there at the very bottom of that, and it declares the port that it's going to run against. And so when we install this deployment into our Kubernetes environment, it will spin up those 3 pods. They'll be up and running. You could even go to that UI that I talked about, and you could see, wow, I've got this new replica set that has been created by that controller. I can see that I have 3 of 3 pods running in that replica set. Hey, what happens if I want to scale that up? Again, you could be using the REST API or the kubectl or this UI to do that. What if I want to scale up to 10 of those web servers? Great, now I have 10 of 10 pods up and running. And you could drill down and look at those individual pods and look at the log files on those individual pods. So this works really great for a web server because it's stateless. All that's really happening is there's a service definition in front of that web server that can do round-robin scheduling into however many number of pods I have up and running as that web server. And that's quite simple. Those service definitions can be a little more complex about how it makes decisions about where to schedule things, and so you can get some nice functionality out of that. But the nice thing here is each one of these pods that's up and running looks exactly like any one of the other ones. And there's not a lot of complex logic. When it's joining in as pod 10 of 10, 10 of 10 looks exactly like pod 1 of 10. So that means that you can kind of use the same template. You don't have a lot of complex startup logic. Again, that's different if you're trying to run a master-slave setup with MariaDB, and we'll talk a little bit about that in a moment. In fact, we'll talk about that right now. But I would pause again and take a quick check to see if we've got some questions here. So I did have a question on how much overhead is saved in using containers versus VMs. Again, there's two views to this. One is if you're just running one container on your physical machine versus one VM on your physical machine, the container is a little more lightweight and it's going to be faster, but I'm willing to believe, the claims with VMs about, maybe a 5% overhead. It makes a big difference when you start to run many, many containers on one machine. I skipped over a very, very important part on that slide. I'm actually glad this is reminding me. The other really big advantage of containers versus VMs is they can start up much more quickly. So you can really start up a container in less than a second. A little bit depends on what some of the custom initialization scripts look like. Whereas VMs could take considerably longer to start up. And this turns out to be a real game changer, right? So now you can on demand scale your capacity by spinning up new containers. The VM startup time, again, depending on how heavyweight those VMs are, can be much, much longer. And this ability to spin up and spin down images, running processes really, really quickly ends up being a real game changer for the way that you can dynamically scale your application. Okay, interesting question here on databases and microservices. So should there be a cached copy of a database in a microservice container in addition to a central database server, and how are they synchronized? So microservices or databases, I should say, have been a little bit challenging to microservices, and there are really two deployment patterns that we've seen. We do still see some folks who are doing microservices really at that, application tier level, with the expectation that they're still going to be connecting into a data store that is separately provisioned from those microservices. And there are advantages and disadvantages to that. So, some of the advantages are, you can, have data that's available from different microservices available in that database for reporting purposes and others. But it does break a little bit of the purist model of microservices where you want to deploy everything in that microservice separately and be able to scale it separately. If you've gone this route where each microservice is going to have its own database, then you're probably going to stitch those all together as a deployment. The specific question here about caching, you may or may not choose to have some data cached up in your application tier, either through custom logic in your application code or some of the caching technologies, but you're then going to have a separate database tier for your persistent storage. I have seen some folks who, are really banking on the fact that, hey, I have this distributed, highly available environment. I'm making sure that my application tier is spread out across multiple availability zones, or the equivalent of availability zones if you have a private, if you're doing an on-prem install, and attempt to rely on that distributed nature for their durability. Usually, if you're doing that, you still need at least some kind of a periodic snapshot so you can rebuild from in case of a massive disaster of some kind that brings down all of the nodes in your Kubernetes cluster. So I did have a question on MariaDB versus MySQL. Just real quickly, at this point we are different databases. We were originally created as a fork of MySQL. There's a lot of stuff on our website on that. We've added in a lot of enterprise functionality that you don't find in the community edition of MySQL at this point. So we're trying to take that open source community code and make it a viable solution for your enterprise applications. A few questions I might handle at the end. And a question about what happens when a container is stopped. Does the data go away? And we're going to talk about that right now. So, data durability, what happens when it stops? By default, container storage is ephemeral or temporary. And I kind of already mentioned this in the beginning. You can start a container, it can be up and running. You have local file space that you can write to in that container. As soon as that container shuts down, that file space is lost, right? So it's ephemeral. It's also, containers use basically a special file system that does copy on write. So it's really great for keeping your storage footprint small, especially when you have lots of containers that look the same that are running on one physical machine. But if you're doing a lot of write activity, it can be more expensive to do those writes and then more expensive to do subsequent reads on those changed writes. So long way of saying it's not really a performance file system that you have in these containers if you have a write-intensive application, which a database usually is. So really, this container storage was built for stateless applications as opposed to stateful applications like databases. There is now, and there has been for a long time, the ability to attach to external volumes that are external from the database, or external from the container, I should say. So those volumes can be persistent, or they are persistent by default. Oops, didn't mean to go forward. One thing to watch out for is the Kubernetes concept of a volume is a little bit different than the Docker concept of a volume. And so just, again, if you're using Kubernetes, which most folks are or a flavor of Kubernetes, which most folks are for managing your Docker containers, then be sure that you're kind of following the practices around the Kubernetes volumes. Kubernetes now has native support for a wide variety of different volume types. So it could be local disk that's available on those nodes. It could be, Azure, Google Compute, EBS volumes, Ceph, and many, many others. There is also a new component. It's a new control. Well, it's not even that new. The StatefulSets controller inside Kubernetes is kind of set up to expect that you're going to be using an external volume, and it uses what's called a volume claim to make sure that when you restart nodes, it remounts that exact same volume. I will say this is an area that's really rapidly evolving, and I think there's been a lot of fear around using Kubernetes for databases because of this issue of the durability of the data. And I think you're going to want to watch this closely, and particularly if you're going into production environments, make sure that you've tested all the corner cases around restarting containers and making sure the correct volume gets mapped back in. Another thing I would say is, and I kind of hinted at this a little bit earlier, is, think about how you're going to do data durability, right? So, the classic way of doing data durability in a production cluster for MariaDB is either with something called Galera cluster or with the master-slave setup, where you have, in both cases, you have multiple nodes that are up and running, multiple, MariaDB daemon processes, and they are receiving writes and making sure that the writes are replicated to all those other nodes. So when you're kind of running in that format inside a Kubernetes cluster, you're going to have a separate volume for each one of those. We do have a few people in the microservices environments in particular who have backed away from that and are relying on some kind of a redundancy in the data storage tier. So maybe they're writing to a Ceph volume or a Gluster volume that itself, when the writes are sent to that volume, that itself is replicating those writes at the storage layer to separate locations, with the idea that, hey, if my Kubernetes container fails, that's fine. I'll just restart, and I'll know that there is a separate copy of that data that's available in, outside of the availability zone that's currently experiencing a failure. And this is particularly interesting because, it used to be that those restarts were incredibly expensive, again, because it was oftentimes a virtual machine that was going to be starting up, was going to take, tens and tens of seconds to start up. The container itself can start up pretty quickly, so that cost of the restart is gone. But you do have to realize if you're going with this approach, there may be some recovery that you need to have done on the storage copy that you're remounting. There may have been in-flight writes that were happening, and so there's a little bit of recovery that needs to happen as the database starts up. And then also remember that the database itself won't be hot, so you may have to warm up the database to get the data back in the database cache before you're going to get the performance that you want out of it. But it is worth noting that with this fast start of containers, that becomes maybe a slightly more viable way to do data durability in production. So cluster formation is another thing that you want to look at really closely when you're doing these production clusters. So how are things like passwords and other things that do need to change from your development environment to your test environment to your production environment? How are those passed in as you promote these to the next environments? Should go without saying, worst, the worst practice is to have those hard-coded right in those Docker files that I was showing. What you'll generally see is the ability to inject this kind of information into those images, either through files that have been staged or through environment variables that are getting set, or through it's really a Kubernetes component called secrets, which is essentially mounting some information that is then available to containers that are up and running based on them having been granted access to that secret. Where it gets more complex is when you want to set up that master-slave setup or a Galera cluster, where each node as he is starting up has to do some extra steps to make himself participate in that cluster. So a new slave that's joining, even though he's still a MariaDB daemon process that is up and running, has to make his specific configuration calls to say, hey, please start pulling the bin log from this master. And so this is where you'll start to see that kind of configuration logic put in one of a number of places. You'll oftentimes, sometimes you'll see people take an approach where, hey, all I'm really going to do is spin up my container as what more or less looks like a standard, virtual machine or physical machine. And then I'll have a separate outside step that goes and logs onto that machine and does the configuration steps that I need to do. So, maybe there's some software staged there, but all of this complexity of doing the master slave setup is more or less still done with scripting, with Chef or Puppet or something. And you're trading away a lot of the benefits of Kubernetes and the seamless promotion from environment to environment if you do that, and you're kind of asking for some trouble. That said, in some of these complex applications that kind of expect to be able to interact with what looks like a regular Linux machine, that may be a viable approach. You will see a lot of those Docker files, they will have at the very end of that Docker file. So remember, it's staging in, hey, this is the operating system that I'm using. This is the patch level. Here's my application code. One of the last things that they generally do is they start the daemon process, right? Well, you can have a whole bunch of complex logic in front of that does some detection about, hey, what's my, am I part of a cluster? What kind of configuration settings do I need to do? So in some of the template examples that I'm going to give you pointers to, you'll find these entry point scripts, or sometimes right in the Docker file as a command, some pretty complex logic that does that. You'll see it doing, DNS dig calls to find out who else exists in my replica set, and some relatively complex logic there. There is also kind of an emerging idea, I would say, of having custom resource definitions and custom operators. So this is the idea where, instead of just running a stateful set, there would really be a Kubernetes separate component that has been coded called, the MariaDB specific, replica set. And that component would be installed into your Kubernetes cluster. Operators have always existed. I mean, a replica set itself is a form of an operator. StatefulSets is a form of an operator. But there's now this idea that perhaps the database vendors would code and release their own custom operators instead of just simply leveraging these existing operators. So that's going to be an area to watch in the future. There is also this idea of watching event streams as containers die or become unavailable. You could subscribe to a set of event streams and then decide what to do. This was a big topic about a year or 2 years ago, and I really don't see it as something that people are investigating at this point for managing these kinds of complex distributed applications. So somewhat related to that idea of cluster formation is, how does a cluster heal itself when a container, exits or fails and then has to restart? So as you're evaluating these various templates that exist out here for the more complex deployments, you'll want to ask those questions, right? So you want it to be seamless to your application, but you want those nodes to be able to drop out and to join in and hopefully reconfigure themselves on the fly. So just a few pointers, and I'm going to start, I'm going to mention sort of my opinion on the current state of databases in general with containers and the current state of MariaDB. So, I've been talking to a lot of clients about MariaDB over the last year and with some of the other databases, for the last couple of years. 2 and 3 years ago, everybody had a little science project that they were starting up with databases and containers. Oftentimes, really, it was starting with the application servers, but nobody was really running them. Right now, we do see a lot of people in test and development environments running their databases on containers. And this is a really nice match with that desire to, hey, pack as many environments as possible on that single frame, right? So in your development environment, maybe performance is not such a great concern. You can be pretty aggressive about packing a lot of those environments on one of your machines. It's nice that your developers can have their own separate environment and make their code changes and not, risk, interfering with coding that other folks are doing other than on a performance standpoint. But in part because a lot of the issues we've just talked about, the complexities around durability and managing these replicated databases, we don't see a lot of people yet using this for production instances. And that's a little unfortunate. We would like to kind of realize this full dream of, hey, I'm deploying my full application exactly the same through all these environments. What we have right now are what I would characterize as some templates from various sources that show how you might do this. But it's very much, again, in my opinion, kind of a buyer beware and treat these as templates. So first off, if you go to Docker Hub, you'll end up finding your way to the official Docker single instance Docker image, which does run against a volume, so you can get durability on your single node. So when you shut it down and restart it, you'll still have your data, but it's not running Galera or master slave slave. Interestingly, this one that's labeled as official by Docker Hub is really still community built. It's not something that MariaDB, the company, has created. There is also an interesting one for master slave setup by a company called Bitnami, whose business is kind of around packaging up existing software for deployment into Kubernetes. I would encourage you to take a look at that. I've not run this one myself, but it looks pretty well engineered in terms of injecting things like passwords and configurability into the environment, and certainly has is probably a leading candidate for the way to get master slave done. Likewise, there's one for Galera cluster, community built, and there's actually an interesting webinar that was done a little while ago that kind of shows building a sample application against that Galera cluster definition. So you get to have a look at what a full application deployment would look like running MariaDB with the clustering technology. So column store, some of you may not be familiar with column store. This is our analytics database that is really tailored for batch queries. against very large data sets. So think of this as a competitor to other analytics databases like Teradata or Vertica or an Amazon Redshift. And it has some kind of unique challenges around getting it to run in a container environment, in part because the database itself has multiple tiers. It has a storage layer tier and then a query access tier. So early on, when I joined MariaDB, I was really anxious to test this, this complex piece of software, our analytics database, in really interesting configurations where I had many nodes running. And so I went through a little project where I used a single install of Kubernetes on my laptop to do that. And so you can go to my GitHub to look at that multi-node setup of MariaDB AX on Kubernetes and listen to a webinar that I hosted a while ago on that. It's actually kind of more of an example of, if you wanted to get started with Kubernetes, maybe just for your development environments on your laptop, how you could do that. I'm going to talk a little bit about that at the end here. We do have an official single instance image of MariaDB AX if you just wanted to take that for a test drive. That is hosted by MariaDB, the company, and that's that first link that you see there on this page. There is, released, I think within the last half year, a blueprint from the Kubernetes.io folks on how they would do master-slave using StatefulSets. And I am now kind of regarding this as maybe kind of the state of the art and the direction that MariaDB, the company, will go if and when we release our blessed production-ready deployment for a master-slave-slave setup. It uses some pretty interesting features that are available in Kubernetes, including readiness and liveness probes, initialization containers, which are a place where you can put some of that initialization logic as these start up, although you still end up with a relatively complex entry point script into those Docker files. And it is using StatefulSets, which have been around in a beta format for quite a while, but I believe graduated into GA code probably about a year ago at this point. So there's a really detailed write-up if you follow this link that'll kind of walk you some of the pros and cons of that. So at this point, this is just showing that MariaDB AX, the analytics database, up and running. What you're looking at here is remember I mentioned that it had a couple of different layers in its architecture. The PM pods that you see here are what we call the performance modules that actually hold the data, and the UM mods, or the UM nodes that you see here, are the user modules. It's basically the SQL parsing tier that you connect to when you're communicating with an AX database. And I think this just shows an example of also scaling those UM nodes from 2 nodes I had originally to 3 nodes. So let me have a look and see if there's some questions. We're very near the end at this point. So I have a question on encryption. So this is an interesting one. You do have built-in encryption in MariaDB wherever it is running, both encryption on the wire by setting up SSL, which I hope everybody is doing, and encryption of the data at rest. So you can enable that in the MariaDB software itself, and it will store the data encrypted. When you're running in Kubernetes, when you're running in any environment, you may also have the choice of doing encryption really just at the storage layer. So some of those storage technologies that I was talking about, Ceph and maybe Gluster, although I'm not sure, have the ability to define those storage volumes themselves as encrypted, which would then just be kind of transparent to the application. So it's kind of an advanced topic, and it gets a little bit complicated when you then kind of fold in how do I want to manage my encryption keys. That in particular may be a little bit tricky inside the Kubernetes environment, but you have a couple of different ways to get encryption done, encryption at rest done, and it's doable in Kubernetes, but certainly an advanced topic. So another question. Let me see if we got another one. So Kerberos is actually going to be fairly similar to encryption, but perhaps a a little more difficult. So the question I have here is, how about integrating Kerberos security, which is already present in our enterprise system? So here again, MariaDB vanilla, whether it's running on Kubernetes or VMs or on bare metal, does have the ability to support Kerberos. So you can define users such that the authorization happens via Kerberos credentials. This one is going to be relatively transparent to Kubernetes itself. So it's just a matter of sort of your application tier or your ad hoc users as they're making a connection into your MariaDB environment. It's going to pass those Kubernetes credentials to MariaDB. So I think this is relatively transparent to Kubernetes. You just need to make sure that those credentials are that you've defined the server and the users to require those Kerberos credentials, and that you're indeed passing those down from your clients. A couple other questions here. Actually, that's kind of it. So for those of you guys who are brand new to containers, so there's a couple of ways to get started, and some of those orchestration vendors that have now adopted Kubernetes, OpenShift comes to mind, now have really good installers also for sort of the single node install if you want to take Kubernetes for a test drive on your laptop. When I started, the gold standard was Minikube, which is a project that is more or less supported from Kubernetes.io. At this point, you're running, vanilla Kubernetes. Lots of great tutorials on how to get this up and running on your individual, single node environment. You do end up with sort of a little bit of what at first looks like a complex setup. For example, on my laptop, I have my physical laptop that's running. I've installed Minikube, a set of software, that's that first dotted line that's running on my laptop. Because I'm running on Apple, because OS X didn't have sort of all of the virtualization hooks that it needs to run Kubernetes, it actually spins up a separate virtual machine. And inside that virtual machine, you're running Kubernetes, and then Kubernetes may be spinning up or is spinning up those individual containers that you want to run. You can still interact with those containers just like through those three methods I talked about, the API calls, kubectl, or the UI. Gets a little confusing in that you can set up kubectl such that it proxies into the Kubernetes environment that lives inside that virtual machine. So I will confess, there's kind of this question of when you're running in a setup like this, what experience are you having, right? We've got these multiple levels. Is it Dante's Inferno, or is it like a really fun, neat experience like the movie Inception, which had this dreams within dreams concept? So it's a little bit easy to get lost when you've got these multiple layers. And I had a couple of just tips if you're getting started from my experience. So again, do those tutorials. Don't make the mistake of trying to jump right in to running, one of the more complex things on top of Kubernetes. Don't go right for a stateful application on Kubernetes. Go ahead and do the Hello World tutorial. It'll really solidify your understanding of what these pieces are, these core pieces, the Docker file, the image, the container, the replica set. If you try and go straight from MariaDB, you're gonna get confused. On that note of those multiple layers that you can get lost in, I just found it really useful to have separate colors for my terminals that were logged in at those different layers. You will have to make a selection of what hypervisor that you want to run. If you're not running on a Linux machine, if you're running on Windows or OS X, you're going to have this VM layer that's installed kind of on top or first to encapsulate everything that's happening in Kubernetes. For OS X, VirtualBox seems to be the preferred hypervisor. I had good luck with that. Minikube has a different release schedule than Kubernetes. So as you get the most recent version of Minikube, you may find that you're a few versions behind the latest release of Kubernetes. There is a way when you start up Minikube to bootstrap in the more recent version of Kubernetes, and I guess that's the 6th bullet point there. And then lastly, setting the kubectl proxy setting is done with that setting there. And this allows you to interact with your Kubernetes environment straight out from your laptop as opposed to having to log into the virtual machine. Okay, that's it. We're more or less on time, and I don't know. I'll take one last check to see if we have questions. Do I have clients that are running MariaDB on containers in production? So we have a few that are kind of in the experimentation phases. We do have some that are running in that more simple microservices setup that I talked about, where they're really just running a single MariaDB, and then they're relying on some kind of storage tier redundancy to spin up the container in a different location if they lose their container. We do now have a couple people who are starting to implement master slave, but I'm encouraging people to make sure that they understand the way those Kubernetes definitions work and that they test some of those corner cases. That's it for now. There's a couple of other questions that I'm really going to handle via email as opposed to online right now, and we're pretty much right at the top of the hour anyway. So I want to thank everybody. I think we're going to see a lot of changes in this space. I want MariaDB to get to the point where we are publishing Kubernetes files. If you have a big project and your company has a big push to containers and Kubernetes and wants to see that, we would love to talk with you, because we want to make sure that what we're going to be producing is going to be a good match for what you guys need. So please reach out to us as you embark on your MariaDB and Kubernetes adventure. Thank you very much.
Great. Well, I'd like to thank Thomas for a wonderful presentation today. I'd also like to thank today's sponsor, MariaDB, for providing the DZone audience with a great webinar presentation. And lastly, thank you to everyone who joined us for today's presentation. We hope you learned something new that will help you in your developer career. Have a great day, and we'll see you next time.